And I think we covered this last time, no?
Yes.
Okay. We talked about this as well?
Yes.
Okay. So if you remember, just a quick recap on what we covered. We started talking about the model-driven engineering. We started talking about all possible abstract models we can have and all the layers. Okay, that's important, don't skip it. So we have conceptual models, logical models, and physical models. We talked about how high level it's providing details to you and how can it be a channel of communication between end users, designers, developers, just to clarify the business logic more and more. Then we started talking about two types of models. Do you remember? What were they? No.
Design model.
Structured and? Structured. Structural and behavioral.
Oh yeah.
Right? We said context diagram. Remember context? So these ones.
Behavior.
These ones. What do we consider them? That's structure or behavioral?
Behavior.
So I can see that this system is interacting with other systems.
This is structural.
Do I know how this system is built?
No.
So this is
Behavior.
behavioral. Interaction means behavior, right? So what do you expect in terms of input and output, right? Who are the key entities that deal with this system or this entity, yeah? So here, context diagram come in to simply clarify the behavior of the system. Then we started discussing these two, structured and behavioral models. Under structured, we only talked about the class diagram so far, right? And here we said we have sequence diagram, activity diagram, use case diagram, and state diagram, which is going to be our focus here. These two in general, and this one, we call them interaction models. We'll see this later, okay? All right, so in the class diagram, we agreed it's usually split into name, attributes, properties, and we can add signs indicating the level of visibility, like how you access, public, private, protected, or let's say default. And then we discussed the types of relations we can have. So association, dependency, aggregation, composition, inheritance, and realization. And we said this one represents a long-lasting relation. Yes? So it means the student is taking the course. Even if that course finished, you're still taking another course. So this relation in general between the two classes will be long-lasting. All right. Now here, dependency, we discussed here the temporary use of something, right? Like when someone reads a book, when someone finished, let's say, watching a movie and stuff. Then we jumped into subsets when we discussed the whole and the partial. So the whole means you have a big entity, and part of this big entity is simply partial entity, yeah? And then we discussed the level of existence. So if this one vanishes, will the address remain?
Yes.
So you graduated from Al Faisal. Is that affecting at any point the address of the university?
No.
Yeah, so the address remains. Now the circle is vanished. Will the center point exist?
No.
So this vanishes when this vanishes, right? We also discussed here the concept of inheritance, which is a clear application of what? Extends in our code, right? Where do we see aggregation and composition, by the way? In coding?
Abstract.
No. No. Far away.
Inheritance.
No.
Interface.
Okay, let me explain this. I'm pretty sure you didn't cover it yet. But let me introduce. We will, I think, talk about it also in SE220 when it's time. Okay. So far we've taken so I can have class X, let's say, all right? And I could have also another class Y. I can say that Y extends from X, which make this one parent superclass, and this one remains a subclass, child class, right?
Yeah.
So we said this one can use what? Can use all attributes, yeah? All methods from parent class, but not constructor. Agree?
Yes.
Also, if here you have a level of visibility, let's say, that's set to be private, can I access?
No.
No, because again, this is a separate class, so we cannot really use it. Now, when we start talking about another concept, so we have class X, then part of your class X will be another class, you call it Y. We call this inner class. Okay? Now, how different is that scenario from this one?
That one has access.
I can access attributes, I can access
Methods.
methods,
As well as constructors.
constructors, and if I set here anything to be private, can I access?
Yes. Yes.
Because now this is a subset of this class, right? So it's a member, so it has full access. So now this is one difference, but this here tells you the whole and the part. Then the level of dependency can tell you whether it's aggregation or composition, right? So if this one can vanish, if this one here vanishes, then this is composition, right? If it will stay regardless, then this is aggregation. One more thing, how would you access, let's say, something, a member inside this group, inside this class? Let's assume here I have int C, for example, inside the inner class. Can I still access this?
No.
Yes.
How would you do it? So here, if I have M, I would just say what? X dot M, right? But if I want to use Z, I would say X dot Y dot Z.
Class name dot class
So
name.
parent, then this subchild, then Z. But now do you see the power of inner classes?
Yes. Yes.
We will touch base on it actually when it comes to SE220. I think next chapter we will. But this is a complete scenario where you can apply aggregation and composition. Inheritance, we know it already, so we've seen it already in extends. When it comes to realization, this is simply interfaces. And again, the way we read it is up, down. Remember? So we said an owner could belong to, could be the person, or could be, let's say, a company. Yeah? Like we've seen, for example, with the cars. People can own it if they pay cash, let's say. But if you keep on using installments, then this could be a property of the bank, let's say, till you own it. And so on. So this is one scenario. All right. We discussed this concept, if you remember. Instead of saying person, we simply put it in one class and we say this is recursion. Yeah? So now a person could marry a person. A person could marry a maximum of one person.
No.
Let's keep it on. Let's keep it on. And a minimum of new people, right? So they can be unmarried or simply married to someone. Okay? Here it's a relation between two classes. How would we read it? Remember? Let's read left to right first. So a student can take, let's define this as take,
Many courses.
a minimum of
One.
one course and a maximum of many courses. But let's read it right to left.
A course
A course can be taken by
zero.
no students or many students, right? Again, of course, based on the context you are given, so I can provide a case study that has these numbers, okay? But within context, We do. okay? So you can tell what is the minimum value, what's the maximum value you have. So if this was set to be 4, this might be given in the context, yeah?
نكتب لك يعني
0 to 4 in that case. Could be 0 to 4, yeah? So minimum 0, maximum 4. So this value could be given to you in the context, okay? If you're not given it and it seems to be general, then this could be many in that case. Or we will see now different presentations to it. Don't memorize. Don't memorize. So these are different scenarios that represent the same exact issue, okay? These are different. What? Okay. Very nice. Let's use magnifier. What? Okay. So that's what we discussed last time. We could say, remember when we discussed 4 types of relations? We said we could have we could say we have it 1 to 1, right?
Yeah.
We can say it has
1 to
many to 1, or 1 to many, or many to many. Yeah? So we can use this single annotation. We can just say 1, right? So this is one type to do it. This is Posh model. And in edited edition, okay. So in the edited edition, the second one, they can represent also the 0. So here, this is how you do it, like a knot, okay? 0, and this indicates 1. I can do it the opposite way, of course, or I can do it this way with 2 bars. Again, another annotation for Martin. And if you want to do it, let's say for multiple items like this, 1 to many, we said, right? But here, this is 0. Here you can still do it like 1, comma, m, which means minimum 1, maximum many. You can still do it with the dots in between square brackets. Please.
Can you go back and explain the 1 to many? You said it's 1 to many, but then that closed circle is 0. So I'm confused.
This one?
Yeah.
Okay, this is 0 on left. So this knot here represents a 0, only 0 value, but this comes on left side, okay? Again, we agreed, the way you read the model left to right is different from reading it right to left. So here, if this is 0, it means B has this relation to a maximum of or a minimum of 0. Minimum and maximum are the same value, which is 0. Yeah? And the same goes here, right?
Yeah.
Okay. If there is a maximum value that's not 0, then you can put it on top. Okay?
But if it's 0, it's 1 to 1.
0, it's what?
1 to 1. I mean, yeah.
If this
Zero
is 0,
1 to 1.
again, come again.
Like, you said that it's inclusive of 0, right?
Which one?
The one that you were pointing to.
This not?
Yeah.
It means 0.
It means 0.
Yeah, yeah, as if you're typing 0 on top.
So 1 to 0?
No, 1 to n for B.
Okay.
But for A, this is 0. Minimum 0. If you put a value on top, this is a maximum value. Okay?
So what's the relation? So it's 0 to
So-
many?
Here it's,
Okay,
yeah, in that case, it's a minimum 0.
Minimum
For
zero?
eight.
Many to 0, Doctor. Or 1 to 0. When 0 is not there, it's like, it does not exist, you know? There's no relation.
Yeah, if it's 0, there's no relation. Yes, obviously. Like as we saw in the, I don't know, the
Is
person
student
example.
enforced?
This one, it was minimum 0.
Yeah.
So you might have, I don't know, how many person entity you can create, how many objects you can create of this person. Let's assume 100. You might have 10 people unmarried, while all the rest are married.
Yeah. Okay.
Yeah?
Yeah.
So for these 10 people, there was no relation, but these two, they have a relation. But in general, the class itself include this, okay? So here, we can still look into this one. So I can represent many relation just like that. Okay, without any numbers. So these symbols are simply avoiding numbers. Okay, this is, who can tell this?
Infinity.
No.
1 or many?
0 or
It's 1.
1. See that? 0 to 1. Yeah? So you do it like a hollow circle and a bar. Okay? So the bar is 1, the hollow circle is 0. Just know it, okay? Just in case you saw it in a diagram, you would know how to read it. Just that part. This. Just one. No, I'm not asking for every. No. Just these. That's what you need to focus on. Martin, Hosh 1, Hosh 2. And just know this. Just know it. And in case you saw it, you know how to say the same. And it's not different.
Only these are.
When nothing's written down, it's 0 or 1?
Where?
Like, for example, the
Here?
yeah, that one, and then the first one, A, there's nothing written down here.
Skip this. It's not even in use much.
No, like,
So
you know
skip
how
this.
the first one, the boat?
Yeah.
Here,
This represents
A,
0.
there's nothing, but it's 0?
Yes. Yeah. That's how they presented it even here later
Yeah.
in the
What is the
updated
difference
edition.
between the first boat and the second boat?
It's still the same. Here, just the annotation of 0.
Okay.
Just that one, okay? Usually, if you don't have any annotation, it represents 0. Okay, but this might be a bit misleading here. Just skip this one, okay? Here, they present 1 plus, just to say many. Just know the differences. This one is important, the asterisk. In many cases, instead of saying n, we will just use the asterisk. This is also common, okay?
Doctor, would it be like 1 asterisk if it's 1 and many?
1 asterisk, it's 1 to many, exactly. Okay? So just skip that Rambog one, this one. No need. And you know it, just know it. Okay? 1 plus means many. Okay? Okay, so that's how we can see it now. So this model uses the annotation we know. This is 0 asterisk, which is 0
Zero
to
many.
many. This one is
Many.
many. Who can read the model for me now? Left to right. Yes, Lee.
1 to many.
So product
Can
What three suppliers?
has many
Many
suppliers, right? All right. Who can read this model? That link.
how do you read it the other way around?
We'll check this. No, this is 0.
So many supply.
So suppliers could have no
I
products.
could have no, but
Minimum no products.
maximum many.
Maximum you can set.
One.
It depends on the value you put here.
But usually it would be written for us, or
Yeah, of course.
Okay.
In the context, you will be given this. If this was that presentation, how would you say it?
suppliers can have many products.
That kind of product could have
Have many suppliers.
many suppliers. Yes.
For the second one, do you say one doctor can have no appointments or many appointments?
Excellent.
And for each appointment,
But try reading it. Yeah. For
each
one appointment,
it corresponds to one patient.
excellent. One doctor.
Yeah.
And
We're still on the same length, right?
Okay.
Perfect. So that's how we read it, left to right and right to left. Who can try the other one?
Patient could have many appointments.
Yalla Lamar.
Yeah.
Go ahead.
Good. We can say that we can have 0 appointments
Hmm.
or many appointments, but it only refers to one patient. Or
Okay.
sorry?
Yeah, okay.
Okay.
So 0 to many appointments could be set by a single patient.
Yes.
Type read it the right to left.
And one patient can
Hmm.
either have 0 or too many appointments.
Excellent. Type let's build a relation between these two. Can you give the annotations?
A patient can go to one doctor
Just maximum one or a minimum one?
at a time when
Minimum
we're speaking.
Minimum
No, general.
Zero to many.
A doctor can have many patients.
Too many?
And then zero
And zero to many,
patient.
actually.
Zero
Zero to
doctor
many,
can
yeah.
have many patients as well.
That's usually many to many relations, right?
Yeah.
So a patient could have 0, no doctors or many doctors, and a doctor could have no patients or many patients, right?
Can you do it?
Or I can put a condition for you that I have a maximum of 10 patients, let's say, admitted to the clinic every day. How would you represent
A
it?
doctor. A doctor can have
It's only one
0
doctor?
to 10 patients. A patient can have one doctor.
Excellent. Okay, good. So again, the context can change this, okay? Yes,
Can we do 0 to many with this one, or
you can, yeah, obviously.
how would it?
Just that.
No, like the money, it can be 0 to money. Like the suppliers.
It's usually default of 0. The minimum is default 0. Okay.
Yeah.
If you want to stress it, what you can do is add a not.
Okay.
Add a not. So this is 0 to many. If you want to stress 1 to many, this is
One.
1 to many, right? So again, this is going to help you, this annotation formatting.
But doctor, I have a question.
Yeah, try to play with it.
One for the doctor to the suppliers when you specified, the patients to doctor.
Hmm.
Why did we choose 0 to 10?
So it depends on my scenario. I can
Oh.
tell you that in a day, the clinic admits only 10 patients. Part of what's
Many
written.
doctors.
Yeah, it could be many doctors still. Yeah. Could be a single doctor clinic.
But it depends on.
So it depends on the scenario given to you, right?
Okay.
Yes.
هلا for like a patient, he is a patient, so he needs to go to the doctor. So we
Yes.
can't say it's 0, صح?
Okay, I can specify that every patient needs to have a doctor assigned.
Yeah, I'm saying
Yeah.
the opposite. I'm saying the patient has to have a doctor, has to have an appointment, and as a
Okay.
patient.
So this is a minimum 1. 1 too many.
Yeah.
Right? Again, it depends on how you specify this. The requirements tell. See how many possibilities you all brought now? That's what we call what? Ambiguity, right? Don't put something in the requirements document that people will understand differently. You have to be clear. Remember when we discussed the numbers, why we make it very specific? Because of that. Because if you leave it to everyone, the assumption, the design will say something, the development will say something, the testing will say something else, right? So you need to be specific about these numbers. That's an example. We move here from high level to, high level to low level, okay. That's high level, that's low level.
Doctor, what if you want a bit of vagueness because let's say
Fakeness?
the requirements change or the expectations change.
Come again, the first part.
Like, what if you want a bit of ambiguity or vagueness? So
If
that,
you fall into it,
no, you, like, what if it's required? Or what if it's one of the expectations that it's able to be flexible and to accommodate different needs, different expectations?
okay, the thing is, if I'm making the design based, let's say on 0 to many concept, okay? And then people came in the development, they made it, let's say, many to many. You might be given permissions to people who are not authorized to look into these data on your system, right? So if I say, for example, Moodle is implemented to be many to many people, okay? Not this, okay? Let's make it I don't know, voice call, any application that supports voice call, okay? WhatsApp. So a call could be one-to-one, or could be one-to-many, right?
Yeah.
So that's one. So you can initiate the call to many people at the same exact time slot, or you can make it one-to-one. Yeah? Now, the way you implement it, you can implement it one-to-one, but you design it in a way that makes the code flexible. Just like how WhatsApp started, it was one-to-one call. So, then after a few years, they turned it into the many-to-many or the one-to-many call support. So this doesn't mean that you're not supporting in your code. Your code has to be flexible, but you provide what the user wants. So if they are expecting this, you cannot just provide one-to-one call, right?
Yeah.
Now you're just delivering unrequired requirements. That's not actually fulfilling their expectations. So that's what we're talking about. So we try to clear the ambiguity mostly when we introduce detailed type of design. We discussed this already last time, if you remember.
Yes.
I just want to just give you a quick note here. So moving from high level to low level, remember when we said we start with requirements, we end up with a specification? That's simply what we do here. So show first what are these entities and how they interact. Define all possible relations that connect them. Define what are these relations. Yeah? Then once this model is approved or refined, if people requested updates, you move to a more detailed edition. So take each of these and turn it into, this one, for example, turn it into
Human.
an entire class diagram. Same for this, same for this, same for this. Now you can imagine how big this diagram will be, right? But we don't go into the low-level details unless the high-level details are confirmed. Okay? Now, we discussed that? Okay. Same idea. So we're having a bank, a customer, and account. Again, this is not the ideal way to write it, but let me give you the entire format. So this is plus ID ent, right? So plus represent the visibility, name, colon, type, right?
Yeah.
We do it for all of these attributes. When it comes to methods, let me give you an example. We have sum. Let's assume we have double, sum, and x and y. That's my method. How would I present it? We will say, okay, sorry. That's public, okay?
Plus.
So we start plus,
Yeah.
then sum,
Int x and y.
x, colon, and, comma,
Y.
y, colon, and, close, colon,
Double.
double.
What will you do?
That's a method header
أيوة.
in coding, right? So here we start with the name of this method. Before, of course, how would you make it? Public, private, protected? Yes? Then take the first argument, x. It's of type, and, comma.
Second word.
We take y, then of type,
And
and Then the return time of this method, which is double. So for that lower part, I'm expecting this format n, not this. I tried a lot to search for a comprehensive one, but I couldn't find. Many people do it actually the nasty style. You just go for the bare minimum that's required. When you're experienced with it, you can just skip some of these details, but at least learn it the right way, okay? And of course, some of them might just have optional set of methods. You're not necessarily having methods for all classes you have, right?
Yeah.
Okay, let's discuss the generalization now. So we have animal class. This one has attributes and has methods. And I do have 3 samples of animals, like the tortoise, the otter, the snow loris. And ideally speaking, I would have each of them having name ID age, right?
Yes.
But what do we call this? Can you tell me what's the problem with this model?
It's repetitive.
Repetitive.
Also, some of the things that are in the subclasses may not be applicable to the parent.
Nice, very good, excellent. So 2 things. We have a reuse issue. We're not supporting, right? And we have something we know as redundancy. That's the description of repetition, okay? But here, technical term, we call it one of 2 things, either duplications or redundancy. Duplication means like I see name, name, name. This is duplication, right? But when I say redundancy, it means this is entirely repeated, okay? So duplication could lead to redundancy, not the opposite. So here, this model is suffering from the lack of reuse and a high level of redundancy. And this will affect what?
Efficiency.
Efficiency. Every new statement, every new line you add to your code is actually costing you steps, right?
Yeah.
You've taken this in data structure or not yet? Not yet? Okay.
Space and time complexity.
You've taken the big O, the logger. So you know, I'm not going to ask you in this, but I'm telling you. Now try to link, okay?
Okay.
Now this is entirely linked. So we try to, Now we try to reduce this by achieving high level of reusability and no redundancy. So now back to your point. Now we no longer need to, and of course one more actually issue here. Again, the subclass can't share. Like this cannot share this, right?
Since it's private.
Exactly. Not just private. There is no relation.
Yeah.
We don't have relation. These are linked this way.
If we set and get in the superclass,
Yes. Absolutely.